flip-flop or transparent latch can be made from two cross-coupled NAND gates. In this diagram, the two gates are shown connected to a pair of switches which are used to set and reset the flip-flop, and we've got a lamp which monitors the output. The top switch is called, in this particular case, is referred to as not set, and the bottom switch is referred to as not reset. The not meaning that to make the switch active we have to move the switch into the off condition. So in other words, it's active off and inactive on. So taking the switch into the active position, or S bar to 0, latches the output to logic level 1, and if we restore the switch back to its original state, you can see that the output remains at 1. If we take the not R or not reset switch to the off position, we reset the output, and if we return the not R or not reset switch back to the on condition, it remains reset. If we were to monitor the other output from the SR or the RS flip-flop, you'd notice that throughout these three switch positions, these two lamps are always the opposite of each other. So when we move the switch S bar to 0 and we set the latch, Q bar or Q goes to 1 and Q bar, which is referred to as this output, goes to 0. When we reset the latch, and the opposite happens, the Q goes to 0 and Q bar goes to 1. Now there's one condition which we must avoid when we're using an SR flip-flop, and that is when both the switches are in the inactive or off position, because the Q and Q bar in this case would be the same if we were allowed to allow this combination of switches. So we don't allow this combination.